From cosmic dust to climate crisis, the remarkable transformation of our home planet. Imagine witnessing the most incredible transformation story ever told, one that spans nearly 5 billion years and features volcanic hellscapes, frozen wastelands, massive extinctions, and the rise of consciousness itself. This is the extraordinary biography of Earth, a planet that has endured cosmic collisions, atmospheric revolutions, and countless reinventions to become the vibrant world we call. Our story begins in the cosmic nursery of a stellar nebula, where gravity orchestrated the birth of our solar system. Within this swirling maelstrom of gas and cosmic debris, our sun ignited as nuclear fusion transformed hydrogen into helium, flooding the nascent system with energy and light. In the cooler outer reaches, ice and gas accumulated into the giant planets we know today. But closer to our newborn star, rocky materials coalesced under intense heat and gravitational forces. Among these inner worlds, Earth emerged as a molten sphere of liquid rock, constantly reshaped by volcanic eruptions that painted the surface in rivers of lava. The young Earth endured a relentless cosmic bombardment. Asteroids and comets pelted the surface in what scientists call the late heavy bombardment, each impact adding mass and energy to our growing planet. The atmosphere during this chaotic period consisted of toxic gases, hydrogen sulfide, methane, and carbon dioxide, creating an environment utterly hostile to life as we know it. Then came the most dramatic event in Earth's early history, the collision with Theia, a Mars-sized planetary body that struck our world with unimaginable force. This cataclysmic impact ejected massive amounts of material into orbit around Earth, which eventually coalesced under gravity's influence to form our moon. This cosmic accident would prove crucial for Earth's future stability and the eventual emergence of life. As Earth gradually cooled from its fiery birth, a miraculous transformation began. Water vapor in the atmosphere condensed into droplets, and for millions of years, torrential rains fell upon the cooling surface. These primordial storms filled the lowest areas of the planet, creating Earth's first oceans and transforming our world into a complete water planet. Within these ancient seas, approximately 3.7 billion years ago, the first spark of life ignited. These earliest organisms were microscopic and simple, yet they represented one of the most significant moments in cosmic history, the transition from chemistry to biology. These primitive life forms, including early bacteria and archaea, thrived in the warm, mineral-rich waters of the primordial ocean. The early continents began as small landmasses called cratons that emerged from the global ocean. The first supercontinent, Valbara, was relatively modest in size, smaller than modern Australia, but it marked the beginning of the dynamic dance between land and sea that continues. Around 2.4 billion years ago, life itself triggered the first global environmental crisis. Cyanobacteria evolved the ability to perform photosynthesis, using sunlight to convert carbon dioxide and water into energy while releasing oxygen as a waste product. This innovation seems beneficial to us now, but at the time, oxygen was toxic to most existing life forms. This great oxidation event fundamentally altered Earth's atmosphere and oceans. As oxygen levels rose, carbon dioxide levels plummeted, causing global temperatures to drop dramatically. Earth entered its first major ice age, with glaciers extending from the poles toward the equator in what scientists call snowball Earth episodes. During this period, the continents continued their restless movement. Valbara broke apart, and its fragments eventually reassembled into a much larger supercontinent called Rodinia. This massive landmass may have been the largest supercontinent in Earth's history, dominating the planet's surface around 1 billion years ago. As Earth's atmosphere stabilized with its new oxygen-rich composition, life began experimenting with more complex forms. The first eukaryotic cells, organisms with nuclei and specialized internal structures, appeared and began the long journey toward multicellular life. Rodinia eventually fragmented, and its pieces reformed into another supercontinent called Pannotia. During this period of continental reorganization, life underwent one of its most dramatic transformations, the Cambrian explosion, occurring between 540 and 485 million years ago. This evolutionary burst saw the rapid appearance of animals with hard shells, spines, and complex body plans. The oceans teemed with bizarre creatures, including the iconic trilobites with their compound eyes and segmented bodies. This period established many of the basic body plans that persist in animal life today. However, this flourishing was interrupted by Earth's first major mass extinction event around 440 million years ago. The Ordovician-Silurian extinction, triggered by dramatic climate shifts and ocean temperature changes, eliminated the majority of marine species and reset the evolutionary clock. Following the mass extinction, life demonstrated its remarkable resilience by colonizing an entirely new frontier, dry land. The first forests emerged as primitive plants developed the ability to transport water and nutrients through specialized tissues. These early trees transformed the landscape and began the process of soil formation that would support future terrestrial ecosystems. Animals soon followed plants onto land, with early arthropods and eventually vertebrates making the transition from aquatic to terrestrial life. This colonization of land represented another major milestone in life's expansion across the planet. Around 250 million years ago, the continents assembled once again into the supercontinent Pangaea. This period coincided with the most devastating extinction event in Earth's history, the Permian-Triassic extinction, also known as the Great Dying. Massive volcanic eruptions released enormous quantities of greenhouse gases, causing rapid global warming that eliminated approximately 90% of all species. Yet from this near-total devastation emerged new opportunities for evolution. Between 240 and 230 million years ago, the first dinosaurs appeared and began their remarkable 165 million year reign over terrestrial ecosystems. These creatures evolved into an astounding variety of forms, from the massive long-necked sauropods like Argentinosaurus, the largest land animals ever to exist, to fearsome predators like Tyrannosaurus rex. During the dinosaur era, Pangaea gradually broke apart, forming the Atlantic Ocean and beginning to arrange the continents into their modern configuration. The climate was generally warm and humid, supporting lush forests of ferns, cycads, and the first flowering plants. The dinosaur dynasty ended abruptly 66 million years ago when a massive asteroid struck the Yucatan Peninsula. This cosmic impact threw so much debris into the atmosphere that it blocked sunlight for months, causing global climate disruption and the extinction of non-avian dinosaurs. In the ecological vacuum left by the dinosaurs, mammals rapidly diversified and expanded into new niches. These warm-blooded creatures, with their advanced parental care and adaptable behavior, proved well-suited to the changing post-impact world. Among the mammalian success stories was a lineage that would eventually lead to humans. Around 6 million years ago in Africa, early hominids like Sahelanthropus began the journey toward humanity. These early ancestors gradually developed upright walking around 4 million years ago, followed by tool use approximately 3 million years ago. The mastery of fire around 800,000 years ago marked another crucial milestone, allowing early humans to cook food, extend their active hours, and survive in colder climates. This technological breakthrough accelerated brain development and social complexity. By 40,000 to 15,000 years ago, Homo sapiens had become the sole surviving human species. Around 10,000 years ago, humans made another transformative leap by developing agriculture. This shift from nomadic hunting and gathering to settled farming allowed for larger, more stable populations and the development of complex civilizations. The human population grew slowly at first, reaching 1 billion by 1804. However, the Industrial Revolution of the 18th and 19th centuries accelerated both technological development and population growth. By 1927, the global population had doubled to 2 billion, and since the 1960s, growth has accelerated dramatically to over 8 billion people today. Today, Earth faces a new type of crisis, one driven not by asteroids or volcanic eruptions, but by the activities of its most successful species. Human-induced climate change is altering global temperatures, weather patterns, and sea levels at an unprecedented rate. Rising atmospheric carbon dioxide levels, deforestation, and habitat destruction are driving what many scientists consider the sixth mass extinction event in Earth's history. Unlike previous extinction events caused by natural disasters, this crisis is unique because the species causing it, humans, also possesses the knowledge and technology to address it. The question remains whether we will act quickly enough to prevent catastrophic changes to the planet that has been our home for the entirety of human existence. Earth's 4.5 billion-year journey from a molten ball of rock to a vibrant, life-supporting world is a testament to the power of gradual change punctuated by dramatic transformations. Through cosmic collisions, atmospheric revolutions, mass extinctions, and evolutionary breakthroughs, our planet has continuously reinvented itself. Each chapter of Earth's story, from the first stirrings of life in ancient oceans to the rise of human civilization, has built upon the previous ones, creating the complex, interconnected systems that support the incredible diversity of life we see today. As we face the challenges of the 21st century, we carry the responsibility of being Earth's first species capable of consciously shaping its future. The story of Earth reminds us that change is the only constant, resilience is life's greatest strength, and every ending can become a new beginning. What chapter will we write next in this epic tale of our blue planet? This journey through Earth's history reveals not just where we came from, but also the remarkable resilience and adaptability that characterizes life on our planet. As we face modern challenges, we can draw inspiration from the countless times life has overcome seemingly impossible odds to not just survive, but thrive. If you enjoyed this video, don't forget to give it a thumbs up. Share it with your friends, leave a comment down below, I'd love to hear your thoughts. And if you haven't already, hit that subscribe button and turn on notifications so you never miss an upload. Thanks for the support, and I'll see you in the next one.